Fourier transform. Fourier transform. We already discussed Fourier sine transform and Fourier cosine transform. Now we discuss another type that is known as Fourier transform. First we define the Fourier transform. Definition. Let f of x be a function. Then Fourier transform is represented as f of s. Fourier transform is represented as f of s. F of s is equal to 1 by root of 2 pi integral minus infinity to plus infinity f of x e raised to minus isx dx. This is the formula. To find out the Fourier transform of a function, we multiply the given function by e raised to minus isx. Multiplying the given function by e raised to minus isx and integrate within the limit. Here the limit is lower limit will be minus infinity. And upper limit will be plus infinity. Therefore, the formula is after the applying the limit, the result will be multiplied by 1 by root of 2 pi. Therefore, this is the definition. We can do one problem. Find the Fourier transform of f of x is equal to 1 if mod x less than 1, equal to 0 otherwise. Here we have to find out the Fourier transform. Fourier transform is represented by f of s. The function is given as f of x equal to 1, mod x less than 1 is 0 otherwise. Here we have to find out the Fourier transform of the given function. To find out the Fourier transform of the function, first we write the formula. The formula is 1 by root of 2 pi integral minus infinity to plus infinity f of x e raised to minus isx dx. This is the formula. Here 1 by root of 2 pi integral f of x is equal to 1 into e raised to minus isx dx. Here the interval is given as mod x less than 1. Mod x less than 1 means x less than 1 or minus x less than 1. That means x less than 1 or x greater than minus 1. That means x lies between minus 1 and plus 1. Therefore, in this problem, our limit minus infinity to plus infinity reduces to minus 1 to plus 1. The reason behind in that, the problem given that mod x less than 1. Mod x less than 1 means x less than 1 or minus x less than 1. X less than 1 or minus x less than 1. This can be written as x greater than 1. When we multiplying by minus, the inequality will be reversed. We already discussed in the plus 1 level inequality chapter. When we multiply inequality with minus, the inequality will be reversed. Therefore, minus x less than 1, when we multiplying this equation, we get x greater than minus 1. This means the variable x lies between, the variable x lies between minus 1 and plus 1. Therefore, the limit will be minus 1 and plus 1. In all other cases, the function value will be 0. In all other cases, the function value will be 0. Therefore, 1 into e raised to minus isx dx. Then, integrate this one. To integrate this one, 1 by root of 2 pi integral minus 1 to plus 1 e raised to minus isx. E raised to minus isx can be taken as cos sx minus I sin sx. We have a formula, Euler's formula. E raised to minus isx can be written as cos sx minus I sin sx. Therefore, we can written as cos sx minus I sin sx dx. That is 1 by root of 2 pi integral minus 1 to plus 1 cos sx dx minus I into minus 1 to plus 1 sin sx dx. We split this function about cos sx dx minus I into minus 1 to plus 1 sin sx dx. Then we can simplify this one. We can simplify. In order to simplify this function, here we can apply the property of odd and even function. We already discussed this concept in the plus 2 level, definite integral. Here the lower limit is minus 1 and the upper limit is plus 1, equal in magnitude but opposite in sign, and the function is cos sx. We know that cos function is always even function. Here sin sx is a odd function. Therefore, cos sx is an even function, sin sx is an odd function. We have a formula in definite integral minus a to plus a f of x dx is equal to 2 times 0 to a f of x dx when f of x is even, and 0 if f of x is odd. We apply this result we discussed in the plus 2 level property of definite integral. Integral minus a to plus a f of x dx is equal to 2 times 0 to a f of x dx when f of x is even and 0 if f of x is odd. When we apply these results, here cos sx is an even function, and sin sx is an odd function. Therefore, this case will be 0. And this case will be 2 times 0 to 1. This case will be 2 times 0 to 1. Therefore, we can write it as 1 by root of 2 pi 2 times 0 to 1 cos sx dx. 1 by root of 2 pi 2 into 0 to 1 cos sx dx. This can be written as root of 2 by pi integral cos sx, integral of cos sx is equal to sin sx by s, 0 to 1. Then applying the limit root of 2 by pi sin s by s, lower limit will be 0. Therefore, the final answer will be root of 2 by pi sin s by s. Therefore, Fourier transform of the given function is root of 2 by pi into sin s by s. This is the required result. To find the Fourier transform of function, first we write the required formula. The formula says that when a function is given, that function is multiplied by e raised to minus isx. That function is multiplied by e raised to minus isx and integrating and applying the limit, finally multiply by 1 by root of 2 pi. Here 1 by root of 2 pi into integral. The function is given as f of x is 1. Here the function given as 1 for mod x less than 1. Mod x less than 1. Mod x less than 1 means x less than 1 or minus x less than 1. X less than 1 or x greater than 1 minus 1. Therefore, here x less than 1 and here x greater than minus 1. This inequality is reversed when we multiply by minus. Therefore, x in the variable lies in between two value minus 1 and plus 1. Therefore, our limit will be reduces to the minus infinity to plus infinity reduces to minus 1 to plus 1, 1 into e raised to minus isx dx. Then e raised to minus isx can be taken as cos sx minus I sin sx dx. 1 by root of 2 pi minus 1 to plus 1 cos sx dx minus I into minus 1 to plus 1 sin sx dx. Then before we integrating this result, we can apply one property of the definite integral. Property of definite integral says that integral minus a to plus a f of x dx is equal to 2 times 0 to a f of x dx. When f of x is even, equal to 0 if f of x is odd. Therefore, 1 by root of 2 pi, this case minus 1 to plus 1 will become 2 times 0 to 1. The reason behind in that cos sx is an even function. But the second case sin sx is an odd function. Therefore, second part will be 0. Therefore, 2 times 0 to 1 cos sx dx. Then we can integrate this one, cos sx integrate sin sx by s 0 to 1 root of 2 by pi sin s by s. Therefore, our result will be root of 2 by pi into sin s by s. This is the required result. This is the steps. You just look at the steps and write down the 2 or 3 times. Then we can easily write the in examination. Okay. Then we can pass on to next problem. Then we can pass on to next problem. Find the Fourier transform of f of x. F of x is equal to 1. F of x is equal to 1 minus x square for x less than 1, 0 otherwise. Answer. First we write the formula. Fourier transform. Fourier transform formula 1 by root of 2 by pi integral minus 1 to plus 1 minus infinity to plus infinity f of x e raised to minus isx dx. We write the formula. Formula is 1 by root 2 pi minus infinity to plus infinity f of x e raised to minus isx dx. This is equal to 1 by root of 2 pi integral mod x less than equal to 1. Earlier problem we already say that the x lies between minus 1 less than x plus 1. Therefore, lower limit will be minus 1 and upper limit will be plus 1. Then function will be 1 minus x square into e raised to minus isx dx. 1 by root of 2 pi minus 1 to plus 1, 1 minus x square into e raised to minus isx dx. Then 1 by root of 2 pi integral minus 1 to plus 1, 1 minus x square into cos sx minus I sin Sx dx. This is equal to 1 by root of 2 pi integral minus 1 to plus 1 1 minus x square cos Sx dx minus minus 1 to plus 1 1 minus x square sin Sx dx. Here we substitute the function 1 minus x square and take e raised to minus Isx as cos Sx minus I sin Sx. 1 minus x square into cos Sx dx. Then minus I into minus 1 to plus 1 1 minus x square into sin Sx. In order to integrate this one, we can apply the property of definite integral. Property of definite integral. Last class we say that minus a to plus a f of x dx is equal to 2 times 0 to a f of x dx, and 0 if f of x is odd. Here f of x is even. If f of x is even, 2 times. Here 1 minus x square is always even. 1 minus x square function is always even, and cos Sx is always even. Even into even is always even. Therefore, the first part is even function. Therefore, 1 by root of 2 pi 2 times 0 to 1 1 minus x square cos Sx dx. In the second case, when we consider the second case, 1 minus x square is an even function. Sin Sx is an odd function. Odd into even is equal to odd. Therefore, the second part will be odd function. The second part will be 0. The second part will be 0. Therefore, root of 2 by pi integral 0 to 1 1 minus x square into cos Sx. Then our problem reduces to, our limit will be 0, lower limit will be 0 and upper limit will be 1 minus x square into cos Sx dx. Then integrate this one, root of 2 by pi. To integrate this one, we apply the general rule for integration. General rule for integration, first function into integral of second minus derivative of first into integral of second, and goes on. Here we take 1 minus x square as first function. 1 minus x square as first function into cos Sx sin Sx divided by s. Sin Sx by s minus 1 minus derivative of 1 minus x square minus 2x into integral of second function minus cos Sx by s square. Then third case plus minus 2 into minus sin Sx by s cube 0 to 1. This is the integration. Now, to integrate the function, we apply the general rule for integration. To integrate this function, we applied the general rule for integration. General rule for integration says that 1 minus x square into cos Sx, 1 minus x square into first function into integral of second function cos Sx sin Sx by s minus derivative of first minus 2x into integral of second minus cos Sx by s square plus derivative of first minus 2 into minus sin Sx by s cube. Then we apply the limit. Root of 2 by pi. We apply the first limit. Upper limit 1. In the first case 1 minus 1. The first part will be 0. Then second case minus 3 minus, therefore minus into 2 into 1 cos s cos s by s square. 2 into 1 into cos s by s square. Then plus 2 sin s by s square. This is the upper part. When we applying the upper limit, 0, first part will be 0, the second part will be minus 2 into cos s by s square plus 2 sin s by s square. Then minus, when we applying the lower limit, 0, this is 0, and this case is also 0, and this case is also 0. Lower part, all the three terms will be 0. The reason is here sin 0, 0, here x is equal to 0, 0, here sin 0, 0. Therefore, our result will be root of 2 by pi s cube, 2 sin s by s cube. Therefore, 2 sin s by s cube minus 2 cos s by s square. That is, we can take root 2 outside, 2 into sin s by s cube minus cos s by s square. Again we can simplify 2 into root of 2 by pi, s cube taken as LCM, therefore sin s minus s cos s. Therefore, our final result will be 2 into root of 2 by pi, 2 into root of 2 by pi, sin s minus s cos s by s cube. This is the required result in the given problem. 2 into root of 2 by pi, sin s minus s cos s by s cube. This is the required. This is the procedure to find the Fourier transform of a given function. Okay, it's clear. Okay, thank you.